Hi, in this video we'll talk about what are nonlinear regressions and when do we use a nonlinear regression instead of a linear regression. So we use nonlinear regression when at least one of the parameters is not linear. Now the important thing to remember here is we're talking about the parameters, not the variable. Okay. So, a linear regression is where we have a nonlinear parameter, not a nonlinear variable. So, let's give an example. So, let's say y equal to beta x, y equal to a plus beta square x. So, which one is a linear and which one is a nonlinear one? Okay. So, this is beta x square. Okay. So, here it is beta x square and here it is beta square x. Okay, so in this case this is the nonlinear one, this is the nonlinear um, model or nonlinear regression model, whereas this one it's still a non-linear model because it is linear in parameter. Both the parameter a and b are linear in nature, whereas here it is the beta square is considered to be non-linear. Okay, so here is an example and we'll take that to understand what nonlinear regressions are. So we're trying to plot the weight loss versus the days of an obese patient. So he's going through medication. An obese patient is going through medication, and the weight loss is been has been plotted here. Okay, and this seems to be a non-linear pattern, and we'll rather go forward with a theoretically perceived model. So here is one model where the y says the weight of the individual who is going through the medication and is obese, somebody who is obese and is going through medication, so he's losing weight, and it's a the time, function of time, right? With time, the person who is going to lose weight, and how many parameters are there? There is one parameter which is slope. There is a coefficient. So sorry, this is the intercept, and this is the slope coefficient, and there is another exponential parameter theta. So we have got beta naught, beta 1, and theta. Three parameters are to be found out from the data, and of course there is an error term. So I've got the ultimate lean weight, which is the intercept, and then the total amount of weight to be lost with time, and then the time taken to lose half the amount of weight remaining to be lost. So that's given through the this exponential term. So that's basically is the explanation for each of one of these parameters. Now all you need to do is that use the data we have to find out these three parameters, beta naught, beta 1, and theta. So what are the methods to be used to analyze this data? So the method that is to be used to iteratively find it out. Okay, just put the data whatever we have with us and just find it out what is the values of these three parameters. So iterative procedure is one that is very often used. The number of iteration depends on how quickly the parameters converge. So for any optimization problem, we end up with the convergence of the parameters, and how quickly we get these parameters converged will tell us how many iterations are required. The converse parameters are close approximate of the three parameters. They may not completely represent the actual values. They might be very close to what we are expecting. The likelihood of the nonlinear regression is maximized when the residual sum of the square is minimized. So here also we just define a loss function. We define a loss function which takes care of y minus x. Multi x is your independent variables and some sort of a beta. Right here we have beta and then exponential term theta. Um, Sorry, t by theta. Okay, so that's the loss function, and you can actually take the square of that, which gives you the residual sum of square. So iteratively you find out the beta naught, beta 1 and theta for which the residual sum of square or the loss function is minimum. So that's the way you optimize the algorithm to find out the parameters values.